Hey everyone, welcome back. Jason from RGB2Go here. If you've been in the holiday lighting hobby for a length of time, you know that adding moving heads to your show used to mean one thing. And that was stepping up to a full-featured pixel controller, like a Falcon, a Culp, or a Genius, something in that range. Now those are fantastic controllers, but you are looking at a few $100s just to get through the door. So for a lot of people, that's a tough sell when you just want to experiment with a moving head or two just to see if it fits for your show. So not anymore. Today I'm going to show you how to control moving heads for under $50 using the DMX2Go pixel adapter paired with any ESP32 based controller running ESPixelStick firmware. No expensive hardware, no proprietary ecosystem, and if you've already got an ESP32 controller for your show, you might be spending even less than that. So today I'm using my own Solo2Go controller, which normally ships with WLED, but I'll walk you through flashing ESPixelStick onto it. The DMX2Go connects to the Solo2Go with a simple 3-wire cable, and then a standard DMX cable runs out from there to your moving head. For demo purposes, I'm using a 150 watt moving head that I picked up from Amazon, link is in the description. But I wouldn't necessarily reach for one of these for serious outdoor show, but for learning and testing, they're perfect. So let's get right to it. Now first things first, we're going to need to make sure the serial drivers for your ESP32 are installed. I've done this a few times in previous videos, so I won't go over it again, but I will put the link in the description for both Windows and Mac if you need them. It's a fairly simple process. Then, go ahead and carefully detach the ESP32 from your controller. Now we're going to plug it into the PC using a USB data transfer cable. Now, it's important to make sure you're not just using a charging cable. If it's charge only, it won't work. Now point your browser to the ESPixelStick web flasher. Again, the link will be below. When this interface loads, under version, pick the most recent non-experimental release. In this case, it'll be the February 8th version. Under platform, select your controller. As you can see, there's a lot of options here. They've been quite busy trying to make this as compatible with as many ESP32 controllers as they can. Mine is listed under the ESP32 Solo2Go. Now, if your controller is not listed, that's okay too. Just pick the closest match. And we're going to need to plan to verify our GPO settings later, but I'll cover that shortly. Next, set your host name and device name to be something unique on your network. Let's just call that ESPS. See, I've done this before, -MH. It's okay that host name and device name are the same. Under SSID, I'm going to choose the name of my show network and its password. And the AP SSID and password are for fallback access point, which is really handy if you're without a router and you need to connect directly from your phone. I don't plan to use it during this tutorial, but I'll put a default password in there as well. Scroll down, the rest of these settings are fine, then press flash device. Now you may have a situation where you've got multiple COM ports listed and we need to identify the correct one. Typically, the device you just plugged in will be the highest COM port number, and you'll also have the word paired by it. So we're going to select that and connect, and then install ESPixelStick. Confirming again. Now this process can take up to 2 minutes, so we'll just let it run. Once it finishes, click Next, and then open the logs in console. You'll see the system booting, and what you're looking for is this line here, which identifies which IP address your controller has received on your network. Now you can either do this, or if your router supports it, open up a command prompt and ping the device name you set. In our case, we did ESPS-MH. Give it some time for the DNS to resolve, and you'll see the same IP address there. So you can refer to the controller either by the host name or the IP address. Now let's open up the ESPixelStick web interface in another tab. Just type in the IP address Usually helps if I have the correct address. There we go. Now you'll see the very basic ESPixelStick configuration interface, along with its uptime, current time, etc. Now, let's go right to device setup. And then, under primary input, select DDP. Now, you can use E131 or ArtNet, but I personally prefer DDP. If you're planning on using an SD card module and run this controller as an FPP remote, you can use the secondary output for that. The controller saves the sequence locally and only receives timing packets over Wi-Fi. Now that's outside the scope of today's video, but it's a great option to know about. Now under output 1, select DMX. Remember I mentioned before, if you're on an unlisted controller, you're going to need to verify the GPIO assignments. And to do that, let's save settings first. And then go to the admin menu. We're going to enable advanced mode. There's no save button here. And we'll go back to device setup. See, now the GPIO values are listed and they're editable. So just look up your controller's GPIO output and make sure you're using GPIO that corresponds to the output you've selected. Now for supported controllers like the Solo2Go, ESPixelStick firmware already knows the right defaults, so there's no changes that are needed here for us. Okay, now we're going to set the channel account to cover all of my devices. That's a number of devices multiplied by the number of channels per device. I've got a single 12-channel moving head, so I could set it to 12 or just leave it at 64. Either way works fine. Now just a note, speaking of that, DMX maxes out at 512 channels, which is why it's officially called DMX 512. The full universe refreshes at around 44 Hz, which is plenty for moving heads. High refresh rates only matter for pixel-level LED flicker control. Things like pan, tilt, color, they're all perfectly smooth at 44 Hz. So let's click Save Changes. And click OK. And we'll close the web browser. Now we'll unplug the ESP32, reinstall it in our controller, power it up, and we'll verify we can reach it in a browser. So now we can see that our controller, as it is reassembled, does still load in our web browser. Now we're going to open up xLights. Create a new show folder, somewhere that's safe to experiment. I've chosen Test DMX. We're going to head to the Controllers tab and click Discover. Now this won't work with WLED. WLED does not support Auto Discover, but it does work well with ESPixelStick, and your controller should appear automatically, and it does for us. Let's select it and make a couple changes. We have to make just a few adjustments. We're going to uncheck Auto Upload Configuration and uncheck Auto Size. Then hit Save. Now, let's go to the Layout tab. And I've got a 12-channel moving head. The manual that you receive with your moving heads will give you a description of all of the channels and what their functions are. Let's see if I can put that on the screen here. There we go. Now let's drag a new DMX device onto the canvas. There we go. Click on DMX. Choose Moving Head Advanced. Just place it on your canvas. Now in our left-hand window, we're going to set the number of channels to 12, since I've got a 12-channel moving head. Leave fixed channels at 0. Now we're going to map our channels according to our image. Let's see, my pan motor, the coarse control is channel 1, and the fine control is channel 2. Now for my particular moving head, I need to set orient forward to 0 degrees, just to make sure it faces correctly at startup. And for some reason, my pan runs backwards on these lights. So I have to check the reverse CCW rotation. And you're only going to know this by playing around with your individual moving head. Let's save those settings. Next up is tilt motor. According to my charts, the tilt control is channel 3, and the fine control is channel 4. And the rest of those settings is fine. Under color properties, my moving head uses a color wheel on channel 8, not separate RGB channels. But it is possible you could have a moving head where, say, channel 7 is red, channel 8 is green, channel 9 is blue, and you would set those accordingly. But for us, with a color wheel, we're going to configure it as follows. Under color type, choose color wheel. Our color wheel channel, as per our documentation, is channel 8. Our dimmer channel, as per our documentation, is channel 6. And the color wheel size, ours happens to have 8 colors. We'll open that up, and here we will define what those colors are. Now, looking at our image, the first, white, is for DMX values 0 through 9. And that just means that if you choose a DMX value between 0 and 9, the light will shine white. I'm going to try and keep it straightforward here and set that to 0. Next is red. The DMX channel is 10 through 19. Again, to set it, use nice round numbers, I'm going to set that to 10. Next up is orange. And just pick a color here that looks like orange. This is going to show us this color in the canvas when we choose that color. It doesn't need to be exact. Choose the DMX for orange is 20. After orange comes yellow. Set the proper DMX value, 30. Next up is green. Again, it says lime here. It only controls what you're seeing in the canvas. It doesn't need to match exactly. That is DMX channel 40. 50 is going to be blue. 60 is going to be magenta, which is about that. Or fuchsia, as it says in xLights. And the last is cyan. Or aqua. Okay. And I'm going to press save. Now under dimmer properties, I'm not sure why it has us set the dimmer up here as well as down here, but I'm going to set it again to channel 6. Next, we assign the starting channel. If your device is set to start at channel 1, we're just going to select the controller. Set it to port 1. Now, as far as protocol, I just choose WS2811 so it doesn't throw any errors. And you can see up here under our models that channels 1 through 12, the first 12 channels on this controller are assigned to our moving head. If for some reason you had a starting channel that was higher than 1, you would, instead of choosing beginning, you would choose, well, I guess under controller you would choose start channel, and using these 3 dots you would set the start channel there manually. Again, I'm not making any changes here, but that's effectively the exact same setting, channels 1 through 12 on that controller. Again, we'll save settings. Next, let's try building a sequence. Let's click on the Sequencer tab. Choose File, New Sequence. Discard what we were working on before. Let's choose Animation. And Quick Starts. All right. You can see the default settings are for 30 seconds. A 30-second sequence. I'm going to set in some timing marks. And all I do to do that is I click on this timeline with my left mouse button and then hit the T button on my keyboard. I'll do the same thing for 10 seconds. Click T, click T, click T, click T, click T. And we'll use these as our cue points. Now for effects, you've got two options in this bar. One is the generic DMX effect, which we're not going to play around too much with today. And one is the more specific moving head effect. Both do work. And it really is a matter of what feels more intuitive to you, but for today we're going to use the moving head effect. Let's drag it into the first timing slot. Now under the Position tab, see Position Dimmer, then we're going to go up and Output to Lights, so we're going to directly output any changes to our moving head. Now under Pan, we'll choose some settings here. Let's choose a different pan setting here. And we'll see, because we've output the settings directly to our lights, any change we make here will also be sent to the moving head. Let's play with the tilt. Let's then take this effect, copy and paste, Control-C, click in the next time mark, Control-V, that'll bring all of our settings over. Let's change one thing, like change the tilt on it. Now let's do the same thing for the next slot, but this time let's add a color. We'll go to Control, Color Wheel. And it's just as simple as clicking on the color you wish. And as you can tell, the preview uses the red color that we set as we were setting up the moving head. And in our live view, we do see that the red light is on. Let me turn this so it's easier to see what our color is by shooting at the wall. Actually, that's better. There we go. Okay, back to Control. Now you can, if you want a single color, you can unselect red and choose another. Unselect, choose another. Or you can set a queue of lights. So we'll do red, then green, then blue. And given enough time, it will start cycling through those colors. Okay. And then it's just a matter of setting timing marks, copying effects, pasting them, and changing one or two values. I'll do it one more time. Again, I'm not lining up directly with my timing marks, but that's okay. And then we can click at the beginning of our sequence and just let it play. Okay, I'm going to stop those. One more thing that's worth knowing is that every channel supports what are called value curves. So here we were setting the pan, the tilt, and everything to a value between 0 and 255. If you were to choose a value curve, you can ramp, cycle, or oscillate smoothly between values, and that opens up a lot of possibilities. And that's the full workflow, from flashing the firmware all the way to a live sequence controlling the moving head. There is a ton more than you can do once you're comfortable with the basics, but this gets you up and running. Now, if you want to try this yourself, the Solo2Go controller and the DMX2Go adapter are both available at RGB2Go.com. Links are in the description. And remember, it's under $50 to get started with moving heads, and it's really hard to beat that. Thanks for watching. If this helped you out, please hit like and subscribe. Drop any questions in the comments, and I'll see you in the next one. Thanks.